Actually, this is probably one of the harder ones, believe it or not, even though it's matching. This is probably one of the harder ones. I get asked about this a lot. Okay? Okay, so I'm going to have to, I'm going to only be able to talk right now. Okay, so the only thing I can do is talk. I can't write on this screen. They don't give me that option. So what I'm going to do is I'm going to explain to you what I'm doing. Are you ready? You're going to have to ask questions if you don't understand, and I'll do my best to say it verbally. So the first graph, all the way to the left, what are the two possible graphs it could be? Just from its shape. Just from its shape, you can tell it's secant or cosecant. Does everybody understand that? Okay, good. How do I tell if it's secant or cosecant? Exactly, from the asymptotes. Perfect. Perfect answer. So, the asymptotes are at 0, and there's another asymptote at pi, and there's another asymptote at 2 pi. So because secant is 1 over cosine and cosecant is 1 over sine, which would give me an asymptote at 0? Cosecant, because sine of 0 is 0, the reciprocal would mean that the cosecant is undefined at 0. So I can tell you that that's a cosecant graph, right? Does everybody see why that's a cosecant graph? Now I look here, my two options are cosecant or that's it, I only have cosecant, so this is cosecant. There's no choices. Okay? The period's right, the amplitude's right, everything fits. Okay? So the next one, this is either a tangent or a cotangent. You know what, this is the easy one. Let me see if we can make it a little harder. Hold on. Here we go. Okay, this is a little better because we have some shifts, we have some, you don't need to plug values into test. Okay, so here's how we're going to do it. We're going to look at where the asymptotes are. Again, we're going to start with the left. Okay, where are the asymptotes? We have an asymptote at negative 3 pi over 4 and at pi over 4. Very good. So if it were tangent, it would be shifted to which direction? Okay, so the normal place for these asymptotes would be at negative pi over 2 and pi over 2, right? So we've actually, if you look at this, if you put your hands by minus pi over 2 and pi over 2, it's actually shifting the whole thing to the left, isn't it? Does everybody see this? Does anybody not see what I'm saying? Okay, so since it's shifting to the left and it's tangent, it's got to be this one, doesn't it? Because it's shifting to the left, pi over 4. The amplitude is just 1. There's nothing else happening on this graph except that it's shifting to the left. Is the period still pi? Yeah, the period's still pi. So that's the only thing that's changing here, is it's a shift to the left. Does everybody see this? Okay, good. Let's look at the next one. So this is either, so is this the regular tangent function? Yeah, it is actually, because it's going from minus pi over 2 to pi over 2. It goes through 0. At pi over 4, it's 1. And at minus pi over 4, it's minus 1. This is just plain old tangent. Do y'all see that? Okay, the last one. Okay, so now we know this is either secant or cosecant, right? What's the normal period? Well, first of all, is it secant or cosecant? This one's not so easy to tell yet, really. I mean, you have to know a couple of things. So it's cosecant y. Exactly, because the 0, unless you have a shift, that 0 is still staying at 0. I don't see that there's a shift. So I'm going to say it's cosecant. I'm going to agree that it's cosecant for the moment. I'm going to agree. And then I'm going to say, okay, so what is my normal period for cosecant? Two pi. What's the period for this cosecant? Yeah, so what does that mean? Good. It means b equals 2. So now I know it's either 2 cosecant 2x, or it could be something shifted with these secants, right? Because all those three have that property. So far, everybody has that same property. So now the last thing we have to look at is the amplitude. If the amplitude is 2, then it's 2 cosecant 2x. Is the amplitude 2? It's not 2, it's 1. If you look at where it should be, where the minimum is, it's at 1, and if it was multiplied by 2, it should be a 2, shouldn't it? Right? So so it's not 2 cosecant 2x, even though we really want it to be that, because it would be so nice if it was that. It would make it easier, right? But it's actually a secant graph shifted. Now we have to decide if it's shifted to the left or shifted to the right. Yeah, see, that's where it gets tricky. So where would the secant graph, what would the secant graph normally be when it's 0? Where? Is what a 2 or a 3? Do you see the scaling on the next to the graph? The maximum is negative. I don't understand your question, Kirtan. Are you looking at the? Are you able to see the Alex? Okay, so right, the asymptote should normally be a pi over 2 and 3 pi over 2, but at 0, where would it normally be? That's probably the easiest way to check. Because the period's not, at 0, if you multiply or divide by anything, it's still going to stay 0, so that's the really nice place to look. So normally, at 0, the secant graph would be 1, because it's 1 over cosine. Cosine of 0 is 1, so 1 over 1 is 1, right? I'm sorry I can't write anything, so is everybody following me? Or if I'm losing you, speak up so I don't go too fast. Everybody's good? Okay, so that means that normally this graph should start at 0, 1. But notice it's starting at, so the minimum is not at 0, 1, it's at pi over 4, 1, which means what? It shifted to the right. Okay. Oh, but it's pi over, oh yeah. Okay, so here's the rest of it. You have to factor out that 2, don't you? Remember that we talked about, and I can do all this. If you write down this problem, I'll show you what this is when we get back to the whiteboard. I can draw this up for you. So this would really look like, so it's shifted to the right. So basically it's going to be this one. The answer is going to be this one. And what you can do is factor out the 2, and if you do, then it would be 2 times x minus pi over 4 in parentheses, right? Which means it's a shift to the right of pi over 4. I can do this one. I can show you this one on the whiteboard in a minute. Okay, so write down this secant 2x minus pi over 2. We got them all right. Okay, I'm going to go back to the whiteboard unless you have anything you want me to do here for the moment. Calculus and physics, and probably if you're engineering a lot. Yep. Yeah, trigonometry is very important. I had a geoscience major, geology major. He said this was one of the most important classes he took because a lot of stuff he had to do in geology was trigonometry. I've had chemistry majors tell me that there's a lot of trigonometry in the upper parts of chemistry because how atoms react is you have to be able to understand the trigonometry of it. So, yeah, it's everywhere.